All right. So I'm James Kahkoska. I'm the CTO at NetAlly, and really happy to be here. And Well, it's always an amazing event for me. It's interesting. I think as I get older, I just wish I could go back in time a lot of times and just kind of back to a moment, experience how something was, remember how it felt, sort of the beginner's eye experience, and sometimes technology lets me do that. So, for example, this is a Google image, kind of low res, but this is my primary residence in an area called Black Forest, 1989, and then fast forward, and you can just see this is the Black Forest fire wiped out, 500 homes here. All this got built up. This is all new, new, new. Managed to get despite water restrictions, there's a new golf course, right? So you just can kind of see the change over time. So sometimes you can get a sense for that, and so there's other times I have breadcrumbs, right? So as we pulled out of NetScout and became NetAlly, got propped up as our own company. Uh, MFD5 was really our coming out. It's a big deal, but we didn't really have a product. We didn't have Etherscope yet, and so we spent a lot of time kind of building up street cred, and actually almost leaned back into the fluke years, right? But talked about our history of innovation and how we've done products like Link Sprinter, but always a goal was holistic visibility, and so between RF and IP. And so we went into mobility field day 6, and it was largely about AirMapper and the AirMapper ecosystem. Uh, we uh, we uh, we went into mobility field day 7, and at this point, 6 gig APs were rolling out, and the need for N-based T, and so it was largely about a feature we call Lambert, which lets you verify that your old Cat5 cabling would in fact carry without any loss or errors, would carry your N-base T 2.5 and 5 gig. And we also talked about discovery and discovery difference, and started to lean a little bit into security, right? And as we showed a lot of features that we had to ensure proper segmentation, but then AirCheck was G3 was coming along, and so last year, talked about the AirCheck G3 mostly, and just a lot of stuff about how we built our decoder rings, or for BSSID complexity because of multi BSSID beacons and reduced neighbor reports and all that stuff, and so here we are, MFD9, right? And by the way, we'll be back again for Security Field Day next month. It's interesting; these are paired at the same number, and so I went and looked, and you know, relatively nascent relative to Network Field Day at 31 and Storage Field Day at 25. But when I think about going back in time, some moments I can remember very viscerally, and maybe a lot of you had the same experience. But it was probably the first time I sat on my sofa, and I was untethered. It was my first mobility moment, right? In the house, and I was looking at email, or looking at Yahoo, who knows what, but just that I didn't have to be at my desk, right? It was incredible, right? And same thing, right? First digital camera, it just goes on and on. But I think there's just been these technology moments for us. And so it had me thinking about mobility. So, what is mobility, right? There's personal mobility, as I just described here. Let me get a sharp pointer here. But also, recently took a road trip, and streaming podcasts in the car the entire way, right? And so there's kind of big scale mobility, and there's at home mobility, and then it even dawned on me a couple weeks ago. I was looking at all this old stuff, right? Because you don't need any of it anymore, right? In fact, you end up putting cover plates over all the old RJ11s, and you end up putting cover plates all over all the old coax drops, right? And now there's another piece of mobility, which is asset mobility, right? You can prop up anything you want, so you can mount this TV on the wall, put a $20 Roku or Fire Stick in it, and stream anything you want. but you don't have to be at the end of a piece of coax or an Ethernet drop or any of that. And so just a kind of another way to think about mobility. But for most of us, it's about site mobility, right? And largely about floor plans, whether you're in retail. I think it's a big Target superstore. This is an elementary school. This is our office. This is Denver International Airport, right? But it's largely about site mobility. And although there are mobility sites, right? We are mobile sites. During COVID, we had pop-up hospitals, and then there's filming studios. I know both of these because we dealt with them. We were able to keep production going in our factory in California, even though California was shut down, because we had a pass, because we were deemed mission critical, right? So and when you think about sites, right, it's just the sheer amount of complexity that's come along. This is actually a slide I think I did 4 or 5 years ago, but you started with PCs, and then they added VoIP, and that brought in PoE, and then there was Wi-Fi, and then more devices. We went through the whole BYOD craze, about 5, 6, 8 years ago. Then VoIP was the first case, right? These overlay networks just started to come onto Ethernet, right? So security cameras that used to be largely coax, suddenly they're Ethernet, right? And using PoE, and now it's even digital ceilings. So uh, uh, and what's really happened here is this massive convergence. I mean, and it's getting deep, right? I caught the first part of this conversation yesterday, and they're adding specific KPIs around Zoom and Teams, right? And so just this little piece here, but all the ways that largely Wi-Fi is getting used, and the clients are growing. They're super diverse. They're ephemeral. They come and they go, but then you still have this legacy stuff, right? If you're in retail, you got the pile of scanner guns you bought 5 years ago that still need 802.11g. So sites are complex, and ultimately there's a lot of segmentation that needs to happen. It might be by department, because you don't want HR folks getting into R&D folks, or vice versa. By user type, guest, by overlay, VoIP, surveillance. If you go into healthcare, kind of by application, infusion pumps in hospitals mission critical, tend to run on their own SSIDs, and then you got the old legacy stuff, and so it's quite complicated managing the segmentation that you need, right, for proper cyber hygiene, and to keep things isolated to prevent lateral movements. And it's just fascinating to continue to see these stories about, it was a fish tank thermometer that basically pulled the database and pushed it up to the cloud, right? But ultimately this article's right. You can't protect what you don't know, right? And so there's a lot to managing sites. There's also a lot of complexity just in organizations. It's been interesting with CyberScope as we talk to different organizations. I mean, they're just all snowflakes. Do the NetOps people do SecOps? Is the SecOps people do any NetOps? Or if the NetOps person does a scan, does the SecOps person slap their hand? If you're watching the Wi-Fi stuff, if an AP pops up, do you care? Unless maybe it's on a channel that's causing adjacent channel interference, and then there's always this tension of sort of site size and the cost of deployment. Can I put a fixed asset in this location? And what's becoming more and more clear to us is, when you're at the knock level and you're not on the site, that you're getting alarms and stuff's going on, but you don't really understand the physicality of anything. And so there's a lot of power in the point of presence. So visibility is our middle name. You can see it here: simplicity, visibility, collaboration, right? And we've always driven in that way. And so a lot of ways, and I'm going to do slides here for about 15, 20 minutes, but really I want to mostly do live demo. But it's been interesting. We've always found a way into security stuff. About every few weeks, somebody would reach out to me and say, "Hey, can you talk to this person?" Right? And it was everything from tactical surveillance and countermeasure, and the company that does sweeps for the Kardashians, through large retail vendors, trying to see how much stuff is leaking out into their parking lots off of Wi-Fi, and on and on and on. And so we've always had these powerful sorts here, and just makes it really easy to filter. I only want to see open things. I only want to see open things in the 2.4 gig band, right? And so a lot of ability to filter and sort. And we have these progressive filters that as you pick things, the rest of the things go away. I refer to it as sort of the shopping cart model, right? I want men's shoes, I want dress shoes, maybe, all the athletic shoe things go away. So, and then sorting, right? This is a great way to really sort of spot the outliers. So if you're sorting by the number of APs, by the number of BSSIDs, and you see that, and you're focused on your SSID of production, then you suddenly see, you might see that something only has one SSID instead of multiple, right? So there's just a lot of ways to make sure that everything looks the same from a Wi-Fi perspective, and so if you think about looking at Wi-Fi networks from a test and measurement perspective, from our perspective, we've always traditionally had scanning, right? And we break things down into these categories. You can go in and look at all your BSSIDs and sort them any way you want, and we'll see stuff. But since it's in the air, we don't really know what it is, but we know that it occupies a Mac, and we know that there's a switch there, but we don't know much more than that. And so, but when you link, we lose the ability to scan, right? Because the radio can't do both. But we then you can start to have an IP address and interrogate things and understand more what's going on in your network. And this is our linked mode. And so up until a few years ago, you either had to link or scan, like on the AirCheck G2. As we moved into EtherScope, we created the link scan architecture, which allows you to then, let me get this clock out of the way. I'll put it down here. And so when we're scanning all the channels and we're linking, we can then basically take the Macs and go out and find those devices. And so kind of a classic example I use is when we only were scanning, you'd see something you only knew it was a Wi-Fi client and you knew a Mac. Well, once you're connected at the same time, you can basically determine the IP address for that. Once you have an IP address, you can kind of do a port scan and understand what services. Oh, it's running printer ports, and then start to interrogate it for names, right? And printers, and so many things now as consumerization comes into sites. You want to hang a smart TV on the wall to use as a motivational monitor, and so but these things all come out of the box with every possible service turned on. And so just by default, this printer has SNMP, MDNS, so it can play with Apple, and NetBIOS, so it can play with Windows, and SNMP, so it can be managed, and all that. So it's really interesting. As we first got the link scan stuff going, I was fascinated by how I could just go into so many public places, and that there was no client isolation. And so I could basically scan through and know from the RF scanning what channel folks were on, but then through taking their Mac and ARP sweeps, I could start to interrogate and get their names. So this happened to be on a flight, right? And turns out most of the airlines still have, you can still do this. I could go to this. I think this was at the at my gym or car dealership. I can't remember because I'm always playing with this, but you're just literally, you have direct access connected to the network to get to Gabby's MacBook, right? And so as I mentioned, segmentation is key, right? You got to keep things separate. So we've always sort of had this foot in the security space, but we really about 6-8 months ago decided to really embrace it and go after it and really augment with a lot of cybersecurity features. And most of what I'm going to do is I'm going to show you mostly on the Wi-Fi side because this is mobility field day. So we've always had the ability to detect DHCP second offer, for example, and that's kind of interesting because if you were able to put a nefarious DHCP server in, it sort of if it's on site, it's running on a Raspberry Pi or something like that, it takes over. It's faster than the corporate server usually, and so it can come in. So we've always been able to detect that there were second offers and give you a way to find it and hunt it and do path analysis. We've always had the ability to automatically, as we look at services, see things, as we catalog things in our discovery. Hey, there's an SNMP agent here. What is it? Well, it turns out that in fact the public string was still left in place. The default shipped string was left in place on this wireless LAN controller in a very public place. And we've always had these problems that we've detected, largely about NetOps, right? Duplex of interfaces and subnet masks and discards. But when I look at the last year or two, a lot of features we've added actually have a security bend to them. So, for example, one thing we added about a year and a half ago was detecting BSSID changes if a channel changes, right? And so if you had if you were sitting there, we're just scanning on the site, and suddenly, your APs are flipping around channels, it might be because somebody propped up a nefarious AP. It might be just the radio resource management trying to make some adjustments, but you can kind of start to see how some of these features could be used by either NetOps or SecOps. But I'm going to pivot more heavily into just the SecOps things. One more we added this just recently. What 6E brought, I think, for most manufacturers was a huge SKU complexity because in some places you could have Wi-Fi 6 without using the 6 gig band, like China. In some places you could use the bottom half of the 6 gig band, like in the EU, and then there are other places like in the US. And so we started reporting anomalies and on the country codes, and then even started to see things like, well, why is Ubiquity, every other BSSID is reporting, US? Why is this? Why it's looking like a different country code, because you have to take this literally, but they forgot to capitalize the S, right? So we've added a lot of new problems, and I'm not gonna spend too much time on this. I'm gonna demo these live for you, but we have port scans, right? And this is one of the ways we knew that this was a printer, because these printer ports were open, right? But the problem is ports aren't the problem; it's the services that are running behind them. And so one of our strengths is really to, we're a handheld, right? So we have these deployment models, and we've always had this notion of a physical site assessment, and that just gets stronger with cybersecurity, right? The ability to go into a site and not just assess it for all the RF stuff, but also to do just sort of a site assessment for security. A lot of stuff you can do on the unit. Everything it collects, you push up the link live where you can do analysis at your heart's content, and a strong capability around remote and drop in, right? So you can literally drop this thing into a site, FedEx it in. So somebody can just connect it to the guest SSID. You can come in through link live and be running it remotely. So that is coupled with our unencumbered collaboration, right? This is the we at the same time you can be looking at the same site, Wi-Fi heat maps, network analysis, topology, and I'll show you about 4 new ways we just added to look at the site. So when we started going into cybersecurity, one of the first things we did was just take a look at what we had, right? And this is sort of a data flow diagram of what happens in between link live here on the right and the collector. But we really realized we needed to add more visibility. We needed better names. We needed better TCP scans. You had to kind of do it manually on a per device basis. We needed to show you what services are running, what versions. UDP scans have always eluded us because they're not deterministic, right? It's not a handshake. Broadcast services. This is where I mean, DHCP is essentially a broadcast service, but there's so many other broadcast services nowadays where you just send out a packet and it's how things automatically connect, right? And what operating systems are running, we wanted visibility to that, and then we wanted to leverage the APIs that were existing in the NOC and put that power in not just on the NOC big screens, but literally in your hand in the field. So that was our goal in providing more visibility for cybersecurity. So of course it's pretty obvious what to do, right? We nmap was kind of the go-to tool. If you look at in Hollywood, almost any movie uses nmap. Whenever the screen starts scrolling by and they're trying to show stuff going on, it's always nmap, right? And so we started looking at nmap, and it's great, but and it's phenomenal. It's an incredible tool. It's been around for 20 years. It's sort of the go-to initial tool for understanding what's going on, but super complicated. There were a lot of problems with nmap, right? It had these massively cryptic command lines with just dozens of switches, upper and lower case mixed together. Spelling had to be just right on, and how do you, once you've determined how you want to run something, how do you get back to it the next day? How do you can it, basically? And then you get to the output. Well, the reason they use it in Hollywood is because the screens go blowing by and it looks impressive, but it was really hard to interpret, the services. There were the fingerprints of operating systems that would consume pages of the screen, and things like that. And then there was no grading, right? You really had to pour through it line by line and determine what was working and what wasn't working. And then lastly, how do you sort of share it? How do you save it and share it, right? How do you make what you captured, live on so you can compare it in the future? And how do you look at the result of nmap in different contexts, in a topology map, in a heat map, a survey map, in a table, right? So we kind of took nmap and ran it through our simplicity, visibility, collaboration filter, and domesticate it, right? So we could take command lines like this and basically can them with a friendly name. You could grade things. If you don't want any universal plug and play 1.0, you can basically say, I don't want that. We highlight it, and it's all the way through the system. From on the unit, we highlight this particular device has this issue. You drill in, you see that, you push it to link live, you look at it in a topology map, and there it is, right? And then lastly, we wanted to let rather than just doing command line, we wanted to allow you to script it in auto test, automatically apply it in discovery, and even use it when you're deep diving on a particular device. So